You wake up, reach for your phone, and discover that nothing is connecting.
No news. No messages. No messages. No websites.
For a moment, it feels like the internet has disappeared.
But that phrase hides a much bigger question. What exactly does it mean for the internet to die? Because the internet is not one machine. It is a collection of interconnected networks.
Networks operated by different organizations. Facilities distributed across different locations.
Wireless systems.
Physical cables.
And other communication technologies.
All working together.
But the part you normally see is only the final layer.
Your device connects to a local network.
That local network connects to a provider. The provider connects into larger networks.
Wireless systems.
So when your screen says offline, we have to ask where the chain broke.
It could be inside your home.
A local device could have failed.
Your local network could have failed.
The connection serving your neighborhood could be interrupted.
A physical line could be damaged.
And the wider internet could still be operating normally.
This is the first important distinction.
Local failure is not global failure.
Modern networks can have multiple paths. Some are designed with redundancy. Traffic can sometimes move through another path.
That is one reason the internet can survive individual failures. But not every location has unlimited alternatives.
Some locations are more important than others. A failure at a major hub can affect many downstream connections.
The impact depends on redundancy.
Capacity. Capacity. and how many alternatives remain.
Then another dependency appears.
Communication systems require electricity. Cellular equipment needs power. Data centers need power. Some facilities have backup systems. But backup power creates another chain of dependencies. Generators need fuel.
The fuel gauge looks good. I'm checking the mechanical systems for any issues. Everything appears to be functioning within normal parameters. And people need access. Someone has to reach the site.
Someone has to inspect the equipment.
Someone has to repair it.
The perimeter is secure.
Copy. Dispatch reports the source is likely on the second floor.
Roger. We'll verify.
Something's wrong with the core route. Check the diagnostics. Confirmed. Traffic spiking. Engaging recovery protocols.
If operators cannot see the system,
They have less information. This path is unavailable. We need to reroute. I'm trying to override the system. And less information can slow decisions.
This is why communications are considered critical infrastructure. Energy systems depend on communications. Water systems depend on communications. Transportation systems depend on communications. Emergency services depend on communications. Financial systems depend heavily on digital communications. So communications failures can create problems beyond communications. Not because every system instantly stops. But because coordination becomes harder. Copy that. Checking the map now. Affirmative. Route confirmed. Proceeding with information infrastructure. People lose visibility. Now consider the physical internet. We often imagine the internet as something entirely digital. But digital information still travels through physical infrastructure.
Glass fibers.
Cables. Cables. Routing equipment.
And cables crossing oceans. Some of the most important links are underwater.
They come ashore at specialized facilities.
From there, traffic enters land-based networks.
A physical break can therefore become a digital problem.
But again, one damaged cable does not automatically erase global connectivity.
There can be multiple routes.
Multiple landing points. And multiple operators.
The same principle exists inside data centers.
A data center is not simply a room full of computers. It is an engineered infrastructure environment.
Power.
Cooling. Networking.
Physical security.
And people.
A cloud service can operate across several facilities.
Sometimes across several regions.
That distribution can increase resilience. But it does not make every service immune to failure.
A cloud application can fail while the wider internet continues working.
That distinction matters.
An application outage is not necessarily an internet outage.
A DNS problem is not necessarily a backbone failure.
A provider outage is not necessarily a national outage.
Scale changes everything.
Local.
Regional.
National.
Global.
Your experience can be completely different from someone only a few miles away. That is why the sentence, "The internet is down," can be misleading.
The useful question is smaller.
Is the problem my device? Is the problem my device?
Is it my local network?
Is it my provider?
Is cellular service still working?
Is another connection still available?
And what information source still works?
During an emergency, verified information becomes more valuable than speculation.
Public safety organizations prepare for communications disruptions.
They use alternative communication paths.
Different technologies.
Backup capabilities.
Because resilience is about alternatives.
If one path fails,
Another may still carry it.
Checking lines B12 and D42. Status report required.
VO, but alternatives only help if they exist.
Copy that. All systems nominal.
and if people know how to use them.
Inverse Outage accepted the base.
For households, the lesson is surprisingly simple.
Keep essential information available offline.
Keep critical navigation information accessible.
Maintain ways to power the devices you rely on.
Keep important information in more than one form.
Is it all here?
Yes, printed copies of everything.
Thanks, Mom.
And know which functions truly require connectivity.
Not every piece of information needs to remain online.
Most of the time, none of this feels necessary. Because modern communication systems are remarkably resilient. There are layers of redundancy.
Multiple networks. Different technologies.
And geographically distributed systems. But resilience has limits.
The more systems depend on one another, the more fragile they become.
The more important those dependencies become.
A communications failure can therefore become an infrastructure problem.
Not because everything fails at once.
But because each layer changes what the next layer can do. That is the hidden architecture behind an ordinary connection.
So the real question is not whether the internet can fail.
It is where failure begins, which layer is affected, and how many alternatives remain. Because when the internet disappears from your screen, the next mystery is not where the internet went. It is which invisible system failed first.